morning, geometry. We're going to work our way through lesson 5 here of chapter 7. Um, there's a number of things, so it's not just one thing, but I don't think any of these are terrible, but they did cause me to scratch my head a little bit. I had to think about it. Let's start with some of the most easy parts. So um, this is on parallel lines cutting things into proportions. And I think the easiest way to start is let's just think about a triangle. Terrible triangle. Um, I'm pretty good at drawing circles, but triangles, I don't know why. I can't really get that. Anyway, be that as it may. So let's say I have, A, B, and C. And then I draw a line that's parallel to A and B. So I'll draw here. We'll just call that D and E. So AB is parallel to DE. So my question is, see this smaller triangle compared to the bigger triangle? Can you see that those are going to be similar? There's a couple of different ways to prove it, but probably the easiest way is to think about the angles involved, okay? Remember our angle theorem. Okay, so let's look at triangle CAB and compare that to triangle CDE. Can you see that they're going to have one angle the same automatically, right? It's angle C. So now if we can just prove that one other angle is the same, then we can prove that those triangles are similar. And if these are parallel, well then these are corresponding angles, right? So we know that those are the same. We also know that these are corresponding angles, so those are going to be the same. See, it's pretty easy just to look at it and see that there's actually all three angles are congruent, and so you know that these two triangles are similar. If you know that these two triangles are similar, then you know that their sides are proportional. So CE, I don't know the symbol for proportion. Oh yeah, proportional to CB. And all of them, DE, AB, CA, CD, they're both similar triangles, so it's all going to be proportional. That is theorem 7.5. 7.5 just says, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. Okay? So I think we can reason our way through that. 7-6 is just the converse of that. 7-6 says, let's say we didn't know this, but we did know this. We did know that these two lines are dividing everybody into proportional sides. Well, if you know that they're proportional sides, you can turn that on its head and say, therefore, we know that these two lines are parallel. Okay? So it's just a converse. 7-6. If a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. Okay. I think that part, we can handle that. What's next? Next is, do you remember when we did trapezoids, we talked about mid-segments? Well, triangles can have mid-segments too. So the mid-segment here would be whatever is the center. it'd be whatever's the center here, and it'd be whatever's the center here. And if we connected those mid segments, there's going to be, it's theorem 7.7, and the theorem says if you connect the mid segments of any triangle, one of the sides is going to be parallel to another side. A mid segment of a triangle is parallel to one side of the triangle, and its length is 1/2 of the length of that side. So do you remember when we did the mid segment of a trapezoid? Theorem 7.7 has to do with the mid segments. And so let's say we have a triangle, actually a pretty good one there, again better. And you take the mid segment. So let's just take the mid segment here, and we'll connect it to the mid segment of this lower one, and we connect it. Theorem 7.7 says that these two are going to be parallel. And there's a special thing that the length of this is going to be exactly 1/2 of this. And I know you can kind of eyeball that, but this is actually a proof of that. And you can see they're going to be proportionate, but it's actually going to be exactly 1/2. Now, let's say that I didn't do this one, and I did this one instead. So I connect here. This is going to be parallel to that side, and it's going to be exactly 1/2 of that side. If I did this one, this is going to be parallel to that. It's going to be exactly 1/2. Did I already do that one? So if I connected these, can you see kind of like on the trapezoid one? This is going to be parallel to that, this parallel, and the perimeter of this is going to be exactly 1/2 of the bigger perimeter. Okay, that's theorem 7.7. And I think we only have one more to do. And this is one that's just a little bit different. It's a corollary. And it has to do with if we had 3 parallel lines. So let me try to draw 3 parallel lines. Fantastic. And if I cut those with 2 transversals, so I'll go boom and boom. So it says if you have 3 or more parallel lines and they intersect 2 transversals, then they cut off the transversals proportionally. And I think with what we've been talking about, you can see why this is. Let's just extend these 2 transversals till they touch. And you see that it makes, there's a bigger triangle, and then we have a parallel line cutting off a smaller triangle. So we know that from here to here is going to be proportional to there. Likewise, we know the smaller one. We know that this is going to be proportional to that. This is going to be proportional to that. So anyway, it's cutting them all into proportional parts because you can make a triangle out of it. That's corollary 7.1. And 7.2 is, let's see, I think it's just the converse of that. Oh, no, it isn't. It's actually a special case. So let's say that these transversals, let's say they cut that into that. That's congruent to that. It says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So if we know that these are the same, then we know that these are going to be the same as each other. And if I drew another one through here, we would know that these are the same as those. Not that they're all the same as, not that that's the same as that. But you see, because we're just making different triangles here, and so they're going to be proportional. And if these are the same, these are going to be proportional, they're going to be the same also. It doesn't matter how many transversals I draw through there. So that's a specialized case, and that's corollary 7.2. Okay, so I know they kind of gave you a lot here, but I think you can handle it. Just reason through it step by step, write these down, and you can use them for different proofs. Okay, all right, see ya.